Hi everyone, this is your demo lesson for grade 10 science chemistry. Okay, so let's get started with some minds and questions. So recalling from grade 9 science, can you recall what an ion is? So when I say ion, we're referring an atom or molecule with a net electric charge due to the loss or gain of one or more electrons. So basically we're saying this is your neutral sodium atom, and when you take one electron out, or you can even add it, but in this case, when you take it out and you lose one outer electrons, right? Since you use one negative electron, you'll get a positive charge, and this will be your ion, which is sodium ion. Okay. And can you also recall what compound is? Great. So compound is anything that is composed of two or more separated elements. So remember, elements is something that you can find from your periodic table. And your compound is a mixture of your elements from periodic table. So for example, H2, O2, your air, N2, or CO2, carbon dioxide. There are some examples of compound. Alright, so for today, we're going to cover ionic bonding, and we're going to also cover some nomenclature. Alright, so ionic bonding. Ionic compounds are formed when one or more valence electrons are transferred from a metal atom to a non-metal atom. Okay, so when you take a look at your periodic table like this is your periodic table, and you'll see the left side and little small and another huge box on the right side. So on your left, this is your metal, and the one in between, this is your metal, but it's special. So this is called as transition metal. I'm going to write TF, transition metal. And on your right, this is your non-metal. Okay, so for ionic bonding, the electron from your metal is transferred to your non-metal. This is how your ionic bond is formed. And usually a metal cation and non-metal anion is formed. Okay, can you recall what cation is? So cation is an ion with positive charge. What about for an ion? Is an ion with negative charge. Great. Okay, so let's keep going. So the charge of each ion correlates to the number of electrons lost or gained. So let me say back to the mind and question of sodium ion, which was Na for sodium, and plus 1. I'm going to write 1 here. Okay, so we say Na plus 1. Is it cation or anion? Yeah, this is cation because we have plus sign here, right? Okay. But since we have plus 1, it means we lost 1 electrons from sodium neutral atom. Alright, great. So the two oppositely charged ions are attracted to each other by a force called an ionic bond. So let's cover some examples down here. NaCl, which is sodium chloride, your table salt, is 1:1 ratio. And magnesium chloride is 1:2 ratio. We'll cover what that means later. Okay, so here's your little diagram, your Bohr diagram, right? And this is your Na sodium atom, and this is your chlorine Cl. And you should know that the outermost shell is called as valence shell. And the electron, this little red dot here, this little electron in your outermost shell is called as valence electron. Okay, so this is the characteristic of the valence electron. This valence electron want to achieve an octet rule. So when we say octet rule, they want to have 8 electrons in their valence shell in their outermost energy level. Okay, so let's take a look at our sodium. So how many valence electrons does our sodium neutral atom have? So when we take a look at our outermost line here, we only have one valence electron, right? What about for our Cl? Let's count. 1, 2, 3, 4, 5, 6, 7. We have 7 valence electrons. Okay, so in order to achieve our octet rule, to be stable and unreactive, this one valence electron of sodium will be transferred to the chlorine atom, which will make sodium cation and chlorine an ion. And this is example of your ionic bond. Okay, so let's move to some properties of ionic properties. For ionic compound or ionic bond, they are solid at standard ambient temperature and pressure. When you say SATP, we're referring any standard or ambient temperature or pressure, because we wanna get the temperature and pressure value in same condition. Yeah. Okay, so just let you know, for the side note, at SATP, when we say SATP, we're referring 25 degrees Celsius and 100 kPa. Okay, back to the properties. So when we say ionic properties, the ionic compounds are very solid, and they form this solid ionic crystals, which looks like this. And this crystal is also called as salt. Not your table salt, but this crystal is called as salt. Okay, so taking an example of NaCl, so this is your neutral atom, and when one electron is transferred from sodium to chlorine, you will have sodium cation with +1 and chlorine an ion with -1. And each ion will combine and form a solid sodium chloride salt, or this is your ionic crystal. Alright, let's move on to some general properties of ionic compounds. Ionic compounds, they have really high melting and boiling point. Why? Because it's really hard to break the ionic bond in between. Yes. But, however, a lot of ionic compounds are very brittle, which means they're very hard, but they're really easy to break. Yeah. And also, when an ionic compound are dissolved in water and become in aqueous form, they dissociate into their ions. So let's say if your sodium chloride is dissolved in water, this is your water, it will not stay as NaCl, but rather it will stay in the form of Na plus and Cl minus. And now, guess what? You have 2 different ions rather than 1 ionic compound. And this is why your salt water can conduct electricity. Why? Because you have ions. Okay, here's my question. What about a sugar? Because sugar is also called as glucose, and which has chemical formula of C6H12O6. This sugar, even though one is dissolved in water, this will not form an ion. That's why the sugar water cannot conduct electricity. Okay, clear. So let's go to some crossover rule. So imagine when we have the two different elements and you want to make an ionic compound with two different elements, what do? You're going to use something called as crossover rule. Okay, so let's do step by step. So step number 1, write the symbol and with the metal first. Okay, so can you tell me which one is metal between magnesium and iodine? Alright, so when you take a look at your periodic table, you can find your magnesium from your left side and your iodine from your right side. That's why your magnesium is metal and your iodine is non-metal. Okay, great. And always remember, the electron from your metal will be transferred to the non-metal. This is the rule. Okay, let's move to step 2. Write the ionic charge above each symbol to indicate the stable ion that each element forms, and we have to use the periodic table. Okay, so when you take a look at your periodic table, and you can find magnesium here and iodine here, right? But on your top right, in most cases, you'll see a little number here, and you will see the magnesium has +2, whereas iodine has -1. This is called as ionic charge, and this is the number we're supposed to use when we make the ionic compounds. Okay, so you're gonna write 2+ above magnesium and 1- above iodine. And number 3, as the name is crossover rule, we're gonna cross over. So draw an arrow from the metal charge which is 2+, to the non-metal, which is iodine, and another arrow from the non-metal charge, which is 1-, to the metal, which is magnesium. And let's see what we get. Step 4. Fill in the number of atoms from each element with which will follow the arrows. If needed, reduce to the lowest term. If number crosses is a 1, the 1 is not shown. So we don't have to write 1. Okay, cool. So after you cross your number down, you will have magnesium 1. So magnesium 1 and I 2. Remember, we're not writing 1, so your final answer will be MgI2. This is your ionic compound composed of magnesium and iodine. Okay, why don't we do some practice question down here? Practice. Use crossover rule to make ionic bonding. So we have Ca calcium with oxygen. Okay, so get your periodic table and let's see the ionic charge of calcium and oxygen. So when you take a look, you will see Ca on your left, and oxygen on your right. And the number for your calcium is +2, and your number for oxygen is, -2, great. And what do? You just have to cross over. And you will get Ca2. You don't have to write the sign like negative positive. And O2. And since we have same number, we can reduce to lowest term. Right? So we can reduce this into 1. And remember, we don't have to write 1. So your final answer will be calcium oxygen, CaO. Okay, so that's it for the demo lesson today. Hope you guys have fun.